BMW just updated their big daddy of adventure motorcycles, the 1200GS. After the update, it's now called the 1250GS. As the name suggests, the biggest change is in the engine. It's got an 84cc increase in the capacity, which is achieved by increasing the bore from 101mm to 102.5mm. With that, the engine now makes 136 brake horsepower, which is 12 brake horsepower more than the last iteration. The torque is also up by 23 Nm, resulting in a peak torque figure of 143 Nm. But the most interesting part about the engine is the new ShiftCam technology, which is BMW's first variable valve technology. But before going any further, let's discuss how the camshaft and the valves influence the engine performance. When the engine is spinning at low RPMs, it produces low amount of power. So obviously, the engine requires less air-fuel mixture. By using a camshaft with low-profile cam lobes, the supply of air-fuel mixture can be optimized for better fuel efficiency at low RPMs. But as the RPM rises, the engine will struggle to make power since the smaller cams won't be able to keep the valves open for a longer period of time to provide sufficient air-fuel mixture into the engine. At this point, a camshaft with larger cam lobes will be useful. A larger cam will help the valve to open sooner and stay open for a longer period of time to provide more air-fuel mixture into the engine. But there are some downsides to these cams. First, they are really unrefined at low RPMs. And the second, the fuel consumption is worse. Honda was the first manufacturer who invented a proper solution for this problem. What they did was they combined the best of both worlds by including two different cam lobes on the same camshaft for both low and high RPM applications. All of the variable valve timing technologies in existence, whether it's Yamaha's VVA or Suzuki's mechanical VVT, works on the same basic idea. The difference lies in the implementation of the technology. The ShiftCam technology on the BMW 1250GS also works on the same basic idea. But like the others, the way the BMW implemented this idea is a little different. In the ShiftCam technology, each of the intake valves has two cams, a small one for low RPM and a big one for higher RPM. At the non-drive side of the camshaft, there are some specially cut grooves which BMW calls as camshaft gate. A ShiftCam actuator which is placed on the non-drive side of the camshaft pushes a metallic pin into the grooves, which moves the camshaft along its axis. At low RPMs, the pin engages and moves the camshaft along its axis to the drive side to engage the smaller cam for optimizing the fuel consumption. At higher RPMs, a second pin engages into the grooves to move the camshaft back to engage the larger cam for better top-end performance. In this particular case, the VVT technology is only applied to the intake valves. On the exhaust side, there is only a single cam is provided for each valve. But it should be noted that it is possible to include the VVT technology in the exhaust valves too. So there you have it guys, the working of BMW's ShiftCam technology. As always, if you guys find this video informative or useful in any way possible, please give it a thumbs up, or if you loved it, please consider subscribing to the channel. See you guys next time, ride safe.